Hi everyone, my name is Siddharth Deshpande and I'm here to complete the capstone project of Module 5, that is statistics. So I'm here to explain this interview questions, solutions of statistics, which is of any 5 videos. So let's start the video. So the first question is, what is a vector in mathematics? It is very pretty obvious topic that vector in mathematics is something which have both magnitude as well as direction. The difference between the scalar and the vector is that scalar is only have magnitude in it, but vector have magnitudes as well as direction. Let's just take an example, that is speed. Speed is a scalar quantity because it just only have a magnitude, that we call that the car is running at the speed of 40 kilometer per hour, 100 kilometer per hour, etc. But when we talk about the velocity, it has both magnitude as well as direction. When we say direction, in which direction you are going, the motion is going in which direction, either positive or negative. For example, velocity. So we can say velocity is the car is moving with the velocity of 20 kilometer per hour in a positive direction. But if we say the car is moving with the 20 kilometer per hour in a negative direction, means it is moving away from our motion. It is moving away from the motion. So that's what we call a vector in mathematics, which have both magnitude as well as direction. So as it is written here, vector can exist in multiple dimensions, in the one dimension, two dimension, three dimension, etc. So in the vector, we can calculate the magnitude by the formula. Suppose in the 2 dimension, the formula of the vector magnitude is under root of x square plus y square. Because there is only a 2D dimension, so there is a 2 point x-axis and y-axis. So the magnitude of vector is under root of x square plus y square. But when we talk about the direction, so the direction in the 2 dimension of a vector is tan theta. So the direction is basically a tan theta. So here the angle is the direction, so theta is equals to tan inverse of y upon x. So through by this formula we can calculate direction of vector. I've already told how is vector different from scalar. Now there are different options we can use in a vector, like addition, subtraction, multiplication, division, just like we are doing in a scalar addition, scalar multiplication, scalar division, scalar subtraction. Now similarly, how can the vectors be multiplied by the scalar? Nothing in just nothing difficult in this. Just like a simple multiplication, we are multiplying scalar with a vector. For example, this is v is xy is a vector and c is equals to 3 is a scalar. So we can multiply 3 by x and 3 by y. So 3x and 3y is the vector multiplication. So this is very pretty much clear. It is the what is the magnitude of vector, I already told. How is the direction of vector is determined, I already told. Now this is the question which is quite good. What is the difference between a square matrix and a rectangular matrix? So a matrix is basically a combination of rows and column, as we all know that. So square matrix is something that rows and columns are equal. Like for example, if the matrix dimension is 3 cross 3, it means that there is a 3 rows and 3 columns. So square matrix is something which is always have equal rows and equal columns. But rectangular matrix is not that type of matrix. In this the rows and columns are not equal, so it is a rectangular matrix. But in a square matrix, the rows and columns are always be same. So this is the difference between square matrix and rectangular matrix. Now the most important, now the question is, what is backpropagation in machine learning? This is the most important question which can be asked in an interview during a machine learning interview questions. So the backpropagation concept is just a little bit related or connected with the gradient descent. So let me tell you what is the first gradient. Let me tell you what is the first gradient in machine learning. So the gradient in machine learning basically refers to the vector of a partial derivative of a function with respect to its parameter. through this line you can't understand, you get nothing in this gradient descent. So I can tell you. So in the gradient descent problem, it is a you look like a u-shaped curve. In this u-shaped curve we have to find the minimum point in the u-shaped curve, u-shaped curve. We have to find that minima. So gradient basically it is a vector of partial derivative with respect to its parameter. It points in the direction of the steepest increase of the function. In optimization algorithm like gradient descent, the gradient is used to update the model parameter. So basically the gradient is used to update the model parameter in the direction that reduces the loss function. So gradient is basically used to reduce the loss function so that we can reach that minimum point as soon as possible. So in this gradient, one learning rate concept is used that we further studied in the machine learning concept. The gradient helps in finding the optimal parameter that minimize the error in machine learning models. So back propagation is just little bit related to that gradient. So what is back propagation? So back propagation is an algorithm used in a neural network concepts where the when used in neural network concepts, allowing them to learn the data by minimizing the error. Here in the back propagation, we go to the we go to the forward direction and again back propagate to minimize the loss function or error function. So I can tell you, I'm telling you the what are the steps which are used in the back propagation, or what are the steps used in the gradient problems. So first of all, neural network consists of various layers. First of input layer, second is number of hidden layers, and third is output layer. In that middle of the layer there is activation layer also. After that, first of all, the input is firstly it is generally doing for the artificial neural network problems. So the input is going to the input layer, and in that input function the weight is multiplied by that input and goes to another activation function, and it produces an output. So each connection between neuron in different layers has a weight which determines the influence of the input on the output. Now the learning process. So this, we are going to the input to the activation layer, activation layer to the activation layer to the output layer. So this is basically called a forward pass. So in the forward pass, the input data is passed. The input data is passed through the network. Each neuron performs a weighted sum of that input, applies on the activation function, and passes the result to the output function, as I told you before. Now, the network produces an output which is then compared to the actual target. The network produces an output which is then compared to the actual target to compute an error. If there is an error, suppose the error is mean squared, if error is calculated by using a loss function such as mean squared error, or mean absolute error, or binary cross entropy error, or something that. So if the error occurs, then we back propagate. So this is the back propagation concept which is used in machine learning. If the error occurred or error encountered, we back propagate to adjust the weights of the weights, so that we can conclude with the actual output. So this is called back propagation. Basically, the goal is to find the weight that minimizes the loss function. So this is the concept of back propagation. I hope you got it. Now the third question might be, what is Bayes theorem and how it is used? So, Bayes theorem is nothing basically. Bayes theorem is a mathematical formula which is totally based on the concept of conditional probability, which says that P of A by B is equals to P of B by A dot P of A whole divided by P of B. Now, what is that A by B and B by A? So A by B is probability of occurring A, probability of A knowing that B has occurred. So is equals to probability of B knowing that A has occurred, or or P dot probability of A. Now, Now, P of A by B is called the posterior probability. This is called the posterior probability, the probability of event A occurring given that B is true. Now, P of B by A is likelihood, that probability of event B occurring given that A is true. P of A is the prior probability, initial probability of event A before considering B, and P of B is the marginal probability, the total probability of event B. So basically, Bayes' theorem is used totally as a concept of conditional probability in the light of new evidence. Basically, it's particularly useful when dealing with the conditional probability where the likelihood of an event depends on the occurrence of another event. So this is known as a Bayes theorem. For example, so how it's work, Bayes theorem and how it works. Basically, we start with the solid proof, that is P of A, prior probability. That is prior probability that this is what you believe is the probability of A without having a new evidence. Now gather the new evidences. You observe event B and to determine how likely B is if A is true. Basically likelihood. Gather the P of B by A. New evidence. After third is update the belief. Update the belief means posterior probability. Using Bayes theorem, you combine the prior probability and likelihood to calculate the posterior probability. So this is what the concept of Bayes theorem. Now, this is the easiest questions in the statistics. What are some common measures of central tendency and how are they calculated? So common measures, there are basically three types of measures of central tendency: mean, median, mode. I think this is the easiest questions in the statistics. The mean is the sum of observation divided by the number of observations. Basically, whatever the observations are there, we can sum up and divide it by the count of observations. So this is the mean, and median is basically the mid value in that observation is the answer, is called a median. So before calculating median, we just have to do one thing, that we have to sort the observations in a ascending order manner. So this is the crack behind the median, calculating the median. The mode is that, and the mode is the number of observation frequently used, or the maximum used observations are called a mode, basically. So it is the mode is the most frequently occurring value. These measure help summarize data by providing single value that represents the center of the distribution. So this is the basic central tendency of statistics, measures of central tendency basically. Now we can just reach with the 40th question. What are type 1 and type 2 error in hypothesis testing? This is also an important concept in statistics, hypothesis testing. So in hypothesis testing, there are two hypotheses. One is null hypothesis, another is alternate hypothesis. These hypotheses are in opposite to each other. Suppose if one is true, then automatically other is false. Suppose example, if null hypothesis, we can say that the defendant is pre-assumed innocent. So this is null hypothesis, and the opposite of this is the defendant is guilty. So this is alternate hypothesis. So these are the opposite connections to each other. So what are the type 1 and type 2 errors in hypothesis testing? This is the main question. So type 1 error is basically is that we are rejecting null hypothesis. Listen, we are rejecting the null hypothesis knowing that without knowing that the null hypothesis is correct, irrespective of knowing that the null hypothesis is correct. So type 1 error occurs when the null hypothesis is incorrectly rejected, meaning that actually the null hypothesis is correct, but we have some wrong evidences, or might be getting the evidences that the null hypothesis is wrong. So we reject that null hypothesis, but actually the null hypothesis is correct. So this is a type 1 error where we incorrectly rejected the null hypothesis. And the opposite of that is type 2 error where the null hypothesis is wrong actually, man. But we are accepting that null hypothesis. We are accepting that null hypothesis, but actually it is wrong. So this is a type 2 error. You can clearly see that type 2 error occur when the null hypothesis incorrectly accepted, meaning a false negative, and a type 1 error occurs when the null hypothesis is incorrectly rejected, false positive. For example, the null hypothesis is defendant is presumed innocent. This is null H0, basically null hypothesis. The statement is that the statement is that the judge find that he is not an innocent person, even if he is innocent. So this is a null hypothesis because the judge find him as a guilty, but actually he is a innocent person. So it's a type 1 error. We are rejecting actual thing. We are rejecting a null hypothesis, incorrectly rejected. And type 2 error is that the judge finds him guilty even if he is not an innocent person. So it is type 2 error. So basically type 2 error is a false something. It is a false something, and a type 1 error is a true something. So I think you got this. At last, I want to explain one of a numerical question which quite frequently asked in a statistics module. If there is 30% probability that you will see a supercar in any 20-minute time interval, basically there is a 30% probability that you will see a supercar in a 20-minute time interval. So what's the probability that you can see at least one supercar in the period of an hour? 60 minutes. So so let's solve this problem. So we have to calculate the probability of at least one supercar we can see in the period of an hour, 60 minutes. So the probability of seeing a supercar in 20 minutes is 30% or 0.30. So we want to find the probability of seeing at least one supercar in 60 minutes. So how we can calculate? The probability of not seeing a supercar is 1 minus 0.30. It's pretty obvious. 0.70 is the probability of not seeing a supercar in a 20 minutes. So how many 20 minutes are become 60 minutes? 20 into 3, 60 minutes. So 0.70, basically the probability of not seeing a supercar in a 60 minute is 0.70 to the power q, because 3 times 20 minutes, 20 into 3 is 60 minutes. So the probability of not seeing a supercar in 3 consecutive 20 minutes is 0.70 into 0.70 into 0.70. That is 0.343. Probability of not seeing supercar in 60 minutes is 0.343. So, and we minus from 1 minus 0.343 is the answer, because the probability of seeing a supercar in 60 minutes is 1 minus 0.343, that is 0.657. So the probability of seeing at least one supercar in a 60-minute period is 0.657 or 65.7%. So here's my time. Thank you for listening me. Thank you so much.